Hi everyone, we're going to wrap up trig with section 7.4, which is vectors and how you can use those in different applications, and a little bit of talk about what the dot product is. You'll need these sort of topics both in engineering courses or physics or about calculus 3 if you're going on that high as well. And so you'll see these again in other classes. So we're going to just talk a quick introduction of what a vector is. A vector and a scalar are two different things. A scalar is just a number, but a vector is a number representing the magnitude, and then you also have tied with that a direction that you're going. The symbol for a vector is usually an arrowhead, or if it's typed, it's in bold. Sometimes you'll see it in engineering. They'll put what they call a hat on it, kind of like a pointed arrow pointing up. To have a vector, though, you need to have an initial point and a terminal point. And the magnitude is written like you would write absolute values around the vector. And the magnitude is the same thing as the length. And the vector u, which would be written in this notation right here, this vector u, is written AB, not with parentheses, but kind of like with less than and greater than on either side, is given by the magnitude of u being the square root of a squared plus b squared. It's basically the Pythagorean theorem. You're just doing like you would do a squared plus b squared equals c squared. You take the square root of it, the magnitude is going to be positive there, and you'll end up with square root of a squared plus b squared. And then the directional angle comes from tangent theta being the second component of the vector divided by the first component of the vector, b divided by a. If your vector, a vector with an initial point at 0, 0 is called a position vector. And we won't talk a whole lot about what position vectors are, but you will need them when you get to calculus 3 if you're going that high. So what happens is, if I just gave you two vectors, this is vector A and this is vector B. Sometimes these are not bolded, so I'll show you what happens if you were to write it. Sometimes you'll notice that they'll have a arrowhead on top like this to give you the vector on top of the A. Or in engineering, they'll draw a hat like that. Math usually sticks with the arrowhead on top. So vector A would be given like this, vector B given like that. And if we want to do 3A or negative B for the vector, what that does is if you multiply a number times a vector, you're just going to either elongate it or compress it. 3 in front of the A just makes that A be 3 times as long. Same direction, same pointing up to the right. It just needs to be 3 times as long. And so you might end up with a vector that's just 3 times as long as the original one, but in the same direction. A negative makes it just reverse direction. So if it has vector B pointing off to the right, kind of up a little bit, vector with a negative B in front of it will have the same length. It's just going the other direction. So you might have to pretend that's the same length because it's fairly close, hopefully. But that's what a number in front of it does. Makes it 3 times as long. Or if we put a 1/2 in front, it'd make it half as long. And a negative just makes it reverse directions. So we can do operations on vectors just like you could numbers. You can add two numbers, you can add two vectors. You can subtract two numbers, you can subtract two vectors. We cannot multiply two vectors. That's not a thing. But you can multiply a constant on a vector. That's what this third one is. This k would get distributed across on each one. So you can multiply a k or a constant across on each component of the vector, but you can't really multiply two vectors together, and we'll talk more about that in a minute. If you do a negative in front, the negative is just like the constant. The negative gets distributed across on each component. So here it says to find vector, you have a vector A and a vector B, and it says to add them, subtract them, and then take the negative of it. I'm not sure why it's got the big 19 in the corner, so we'll just pretend like the big 19 wasn't there. So we have two vectors. Notice that this is pointing, vector A is pointing at that dot. That dot, since it is a position vector, it's starting at 0, 0, that dot will also not only tell you where it's pointing to, but it will also tell you what the vector A is. So vector A is, oops, that's supposed to be kind of a less than sign, would be negative 8, 8. That's this point right there. And then vector B, it would be 4, 8. That's where that point is. And they ask you to find what is A plus B. So if I added A plus B, this actually has a name. If you add two vectors together, this notation, this adding two vectors together, is actually called the resultant vector. You might see that along the way in something in this class, but you'll definitely see it in other classes if you're going into physics or Cal 3 or something else. So if I do want to add them together, what I do is I just add each component. I would take the negative 8 from vector A and add it to the 4 from vector B. And then I would do it with the second components. I would take it from the 8 in vector A and add it to the 8 in vector B. So this resultant vector, or this addition, would give me a negative 4 and a 16. You'll also notice if you ever graph the resultant vector, the two added together, you will get a vector that comes out in between the original two. So if I did negative 4, 16, I would go over negative 4 and 4, 8, 12, 16 would probably be about right here. And so its vector will come out in between the two vectors that I started with. And that'll happen every time. That's the resultant. If I wanted to do the subtraction one, let's do a different color just to make it be something different. We'll go purple. If I do A minus B, that would be just subtracting the two. I would have a negative 8 from vector A, and now we'll do minus 4 from vector B. And we'll have 8 minus 8. This would give me the vector negative 12, 0. Or if I did negative A just says put a negative in front of the negative 8, 8. And so you'll get positive 8, negative 8. And all that does is take your vector and make it go the other direction. So let's do that same thing again. And I'm going to erase the 21. I guess I pulled that one out of the book. So if I look at my two vectors, my vector A is pointing towards this dot. So vector A must have been 4, 8. Vector B is pointing down to this other dot at 4, negative 8. So if I want to do the resultant vector, or the two vectors added together, I just take the first component from each one, the 4 and the 4, and then I take the second component from each one, which would be the 8, and then plus the negative 8. And so what we'll get is the vector 8 and 0. And remember, I told you on the last one, the resultant always comes out in between. And that would happen here. 8, 0 goes to this point right here. So it's actually the axis pointing. because they are the same distance away from the x-axis. That's why it ends up exactly on the x-axis. If I do the subtracted one, a minus b, I would have the first terms from each one, the 4 and the 4. So it looks like that first one's going to go to 0. And then the second ones will give me 8 minus negative 8. So the 4 minus 4 gives me 0. The 8 minus negative 8 would actually be 8 plus 8, which is 16. And if I did negative a, that would just be put a negative in front of vector a and distribute it across. So that would be negative 4 and negative 8. And that will take my vector a and just make it do a 180 into the other quadrant. So hopefully that's not too bad. Now you can write vectors in two different ways. You could do it in ij form, or we could do it in what we call the standard form with the less than and greater than on either side. ij form comes from the fact that the vector I is the vector 1, 0 in 2 dimensions, and the vector j is 0, 1. And so if you were to multiply a number for a across on the 1, 0 and a number for b across on 0, 1 and add them together, you would end up with the vector ab with the less than and greater than. So if you want to rewrite these in different formats, like for instance, rewrite each vector in ij form, the negative 5, 8 would just become negative 5 times the I plus 8 times the j. And that would be ij form. Or if we did the one at the bottom, notice it has a 0 on it. So it's actually 2 times I plus 0 times j. But 0 times j just is 0. So this part would actually just go away. And so we would just simplify it down to be just 2i, the vector 2i. And you'll see vectors in different classes written in both ways, either the standard form or the ij form. When you get into higher math, you'll actually have I, J, and K when you get to 3 dimensions. So here it asks you to find 2a, 2a plus 3b, and b minus 3a, and this first one is in ij form. You might say, is there one easier than the other? And the answer is no, not really. So these are not bolded. They should have been bolded. So I'll put the little arrows on top. And so 2 times the vector a is just 2 times 2i. That is 4i. That's all you have to do. If I did 2a plus 3b, that is 2 times a, which is the 2i, plus 3 times I plus j. And you kind of just gather your like terms together. This would be 4i plus 3i plus 3j, which is 7i plus 3j. Which isn't too bad, hopefully. Or if I did b minus 3a, that's the vector b just the way it is, I plus j, minus 3 times a, which is 2i. So that's I plus j minus 6i, and gather your like terms together. So this is negative 5i plus j. So then I'm going to do the next one the same kind of way, except I'm going to do a and b in standard notation instead. So 2a would be 2 times vector negative 1, 2. which is negative 2, 4. That's pretty nice. If I did the 2a plus 3b, I would have 2 times negative 1, 2, plus 3 times 3, 0. So I'll get the same negative 2, 4 I got the first time above that, and then I'll end up with the vector 9, 0. And so I have two vectors that I'm adding. I just add the corresponding pieces. So the 9 and the negative 2 make 7, and the 4 and the 0 make 4. Or b minus 3a, that would be the b vector the way it is, 3, 0, minus 3 times the vector negative 1, 2. So that's 3, 0, minus, and multiply the 3 across. Or you could multiply the negative 3 across and add them, it would be the same thing. But I'll get a negative 3 and a 6. So when I subtract them, 3 minus negative 3 would be 3 plus 3, which is 6. And 0 minus 6 would be negative 6. And that would be my two vectors, my two, well, 3 of each one on those two examples. That's really hard to say. That's my 6 answers on those. So hopefully that's not too bad. A lot of just multiplying and adding, combining terms and such. Okay, now let's look and see if we can find the magnitude and direction of a vector. So the magnitude is the length of the vector. And so your magnitude is denoted by absolute values. And so what we would do is we take each one of these values and you square it and put it underneath a radical. That's the formula. Oops, not negative 15, positive 15, and negative 8. Your magnitude is going to be positive, and so 15 squared is 225. 8 squared is 64. So you'll get 289. The square root of 289 is exactly 13. And so the magnitude of your vector is 13. Remember, that's the square root of a squared plus b squared. Your direction comes from tangent. So we would do that tangent theta is b over a. So you'd have b divided by a. So you'd have negative 8 divided by 15. Usually this does not come out to something on the unit circle. So we would do the inverse and say that theta equals tangent inverse of negative 8 over 15. Now when we type this in the calculator, one thing to keep in mind is this is probably going to be a wrong answer. And that's not very comforting, but if I type in tangent inverse of negative 8 divided by 15 in degree mode, this will come out to be negative 28.1 or so. That is not your answer. Your answer is going to depend on what quadrant you're in. Since A is positive and B is negative, that means I went over into the positive direction on the x's and then down on the y's. This is quadrant 4. And in quadrant 4, this is technically a quadrant 4 angle, but we usually try to go between 0 and 360. So I'm going to add 360 to this angle so that I'll get a direction angle actually of 331.9 degrees. And I got that by adding 360 to this angle to get this one. That puts it in the correct quadrant between 0 and 360. So I'm going to do the same thing on part B. Find the magnitude, find the direction. So the magnitude of this vector, -4 and 4 root 3. Again, you start by doing the square root of a squared plus b squared. So this is your a, this is your b. So I'll do the square root of -4 squared plus 4 root 3 squared. And you can type that in the calculator if you really wanted to, but 4 squared is 16. 4 squared 16 times 3 makes 48. And so 48 and 16 make 64, which is 8. So this has a magnitude of 8. My angle, here I would do tangent theta is b over a, 4 root 3 over -4, or that's -root 3. And again, you can do this in the calculator, but this one's actually on the unit circle. Either one you want to do. If you type it in the calculator, you'll get possibly a wrong answer here. If I do second tangent of negative square root of 3, I get -60 doing it in the calculator. This is -60 degrees. Going back over to what quadrant we're in, we have a negative first value, which means we went left on the x's, and then a positive b value says I go up. This is in quadrant 2. And -60 is not in quadrant 2. It would actually be in quadrant 4, like it was above. So to go from quadrant 4 around to quadrant 2, I would add 180 to this. So if I was to add 180 to that angle, I would get a theta of 120 degrees. Or if you looked it up off the unit circle without doing the calculator, you could just find it at 120 degrees. That would be where your tangent would be a -root 3, and where you're in quadrant 2. So either one you want to do. If you're in quadrant 1, you don't have to add or subtract anything. You're in the right quadrant. This is very much like our reference angles that we did back in chapter 2. If you are going off the calculator and you're in quadrant 2, you might have to add the 180. If you're in quadrant 3, you might have to take the 60 and add it to 180 to get 240, so to speak. So just kind of depends on what quadrant you're in. Okay, if you do know the magnitude and you know the direction, you can come up with the vector itself by saying that your components are the magnitude times cosine or sine of the angle. So this A and this B, where it says A equals the magnitude of u cosine theta, B is the magnitude of u sine theta, that would be the A and the B inside of a vector. And so if they ask you to find the horizontal and vertical components, the A, this one, since it's cosine and cosine is your x values, that's your horizontal. And sine is your y values, so that's your vertical component. So if they ask you to find those, then your horizontal component would be A. So I would do the magnitude, which is 50, times cosine 20. And I just have to type that in the calculator. 50 cosine 20. That gives me about 47 if you round it to the nearest whole number. And the vertical would be 50 sine 20. And 50 sine 20 gives you about 17 if you round it to the nearest whole number. And so I could tell you that vector V is about 47 and 17. Now, if they don't ask you to find the vector V, they're actually looking for the 47 and the 17. But that's how it would relate back to the vector. Okay, one of the more important topics that you'll see in engineering, physics, and calculus is the dot product. And I mentioned earlier, you can't actually multiply two vectors together, but a dot product is kind of like multiplying. You could have two vectors like u equals ab and v equals cd. And so we would say that u dotted with v, so this little sign right here, you actually say dot, u dot v equals the first two components multiplied, and then add that to the second two components multiplied. Notice that the right hand side here, this is not a vector. You actually get a scalar. You just get a number. So you do not get a vector when you dot them together. So if your angle theta between the two non-zero vectors u and v, if that is theta, and the theta is between 0 and 180, then you can find the angle between the two vectors using a formula. Cosine theta is the dot product divided by the magnitude of each vector. If your dot product is 0, though, you'll get cosine theta equals 0 on top, divided by the magnitudes of whatever. 0 divided by most numbers are 0. And so cosine of 0 only happens at pi over 2 or 90 degrees. And so we would say that if your dot product is 0, the vectors are perpendicular, or a lot of times you'll hear it said orthogonal. They are orthogonal vectors, and they have an angle between them of 90 degrees. Orthogonal is kind of just a different terminology for perpendicular. Perpendicular is the Latin way to say 90 degrees. Orthogonal is the Greek way to say 90 degrees, but they mean basically the same thing. So we're going to find the dot product between a couple of vectors. So if I want to do 6, negative 1 dotted with 2, 5, that would be 6 times 2 plus negative 1 times 5. That is 12 minus 5, which is 7. And that's your dot product. You just multiply the first two together, you multiply the second two together, and add them up. And you can do this in IJ notation or in the standard notation. On the IJ ones, you do have to be a little careful. You're multiplying the numbers in front of the i's together, and then you'd multiply the numbers in front of the j's together. So if I did 4i dotted with 5i minus 9j, that would be 4 times 5, because that's what's in front of the I, plus what's in front of the j's. Well, the 4i doesn't have a j on it, so that's considered that you have a 0 in front of the j and a negative 9 in front of the j on the second vector. So all we're left with is just 20 plus 0, which is 20. So the dot product is 20. So hopefully that's not too bad. This says to find the angle between the vectors. So the first thing you want to do is find the dot product. So we're going to be using the formula that cosine theta is equal to the dot product divided by the magnitude of each one. And so I find the dot product first. So if I do 2, 1 dotted with negative 3, 1, this would be 2 times negative 3 plus 1 times 1. That is negative 6 plus 1, or negative 5. So in my formula over here, cosine theta would be equal to, and on top, I would have a negative 5. Then I need to come up with the magnitude of each one. So the magnitude of the 2, 1, if I did the magnitude of 2, 1, that would be the first number squared plus the second number squared underneath the radical. That's 4 plus 1. Oop, I left the equal sign off. Which would be square root of 5. So that's one of the numbers underneath. Then if I did the magnitude of the other vector, -3, 1, I would have the square root of -3 squared plus 1 squared. That's 9 plus 1, or square root of 10. Now you don't notice it very well on this problem, but this is a number on the unit circle. You have to do some simplifying and such to make it work out, but it does work out. If you want to try to simplify it, you can. I won't go through that process because most of the ones don't simplify and we put them in the calculator anyway. So I'm just going to plug this in the calculator. So my theta would be cosine inverse of -5 over √5 times √10. Or if you want to make it easier to type in the calculator, the 5 times the 10 on the bottom would make square root of 50. But I'm going to go ahead and type this in. I'm going to get -5 divided by these square roots, square root of 5 and square root of 10. And if you type it in the calculator correctly, this comes out exactly to 135 degrees. That's because -5 over square root of 5 times square root of 10 is actually -√2 over 2. And that occurs in quadrant 2 at 135 degrees. You're going to get an angle either from quadrant 1 or quadrant 2 here, and that's okay because we want angles between 0 and 180. And that's what quadrant 1 and quadrant 2 is. So let's find the angle between these two vectors. Again, using the same formula, it's the dot product divided by the magnitude of each one. But you always start with the dot product. And so I'm going to dot 1, 2, dotted with -6, 3. And so this would be 1 times -6, multiply the first two numbers, then multiply the second two numbers. This is -6 plus 6, which is 0. If you get 0 for your dot product, then it doesn't matter what else the magnitudes are. Because if your magnitude is not 0, which it wouldn't be because you have two numbers other than 0 in there, then the fraction is going to be 0. And if the dot product comes out to be 0, then you automatically know that theta had to be 90 because they're orthogonal or perpendicular. If your dot product ever comes out to be 0, your angle has to be 90 degrees. You don't even have to check anything else. So they may just ask you, are the vectors orthogonal or not? And so this first one's actually the same problem we just did. If they're wanting to know if it's orthogonal or not, all you have to do is the dot product. If your dot product, this orthogonal just means that your dot product it comes out to be 0. So that's what you check. Check your dot product. And so on this first one, if you dot together the 1, 2, we just did it, but I'll just write it out again. This would be 1 times -6 plus 2 times 3. This is -6 plus 6, which is 0. That means, yes. Are they orthogonal? Yes. This is, yes. It is orthogonal. Or they might actually want you to write the word orthogonal. I think I spelled that wrong. We'll put an extra A in there. On the second one, though, if you notice, if I do the dot product between 1, 0, dotted with √2, 0, I'll end up with 1 times √2 plus 0 times 0. That is nothing but the square root of 2. It didn't come out to be 0 So these are, no, this is not orthogonal. Your two vectors of I and j are actually orthogonal vectors because one of them is the vector 1, 0, the other one is the vector 0, 1. So if you were to do the dot product between them, that would actually be 0. So your I, j vectors are orthogonal. And so that concludes trig for the summer. So hopefully that all made sense. If not, just rewind them all, watch them all again. And if you have questions, just let me know.